Dear students, good morning. Hope you all are fine and safe at home. In previous lecture, we have learned about elements and their classification, Dobberinius triad, Newland's law of octave, and Mendeleev periodic table. Students, today we will study about modern periodic table. Before we start with modern periodic table, let us recall what we have studied in previous lecture. Students, we have studied that more and more elements were discovered in course of time. Many scientists adopted different methods to classify them. Among them, first one was Dobberinius. He arranged group of three elements in increasing order of atomic mass. Dobberinius concluded that mean atomic mass of first and third elements is equal to atomic mass of second element. Next, we saw Newland's octave. He arranged the elements in increasing order of atomic masses and compared the characteristics with Western musical notes. Then next comes Mendeleev. He believed that atomic masses is fundamental property. Here, fundamental means important property, and he stated that properties of elements are periodic function of their atomic masses. Students, Mendeleev tried to explain in this law, if the elements are arranged in the order of increasing atomic masses, that is by their weight, then those with similar properties are repeated at regular intervals. We also saw that Henry Moseley discovered that atomic number is the most fundamental property of element, not its atomic mass. It means the priority was given to atomic number to arrange the element in periodic table. Students, now let us study about modern periodic table. When Mendeleev's periodic table was discovered, scientists did not know anything about interior of atom. Here, interior of the atom means inside the atom. After the discovery of electron, scientists started exploring the relationship between electron number of an atom and atomic number. Hence, number of electrons were helped to conclude its atomic number. Let us take an example of hydrogen. Hydrogen have one electron. Therefore, its atomic number is 1. Similarly, if we take an example of helium, number of electrons in helium is 2. So, its atomic number is 2. So, this rule is followed to identify the atomic number of all the elements. In 1913 AD, Henry Moseley performed an experiment using X-ray tube. He agreed that atomic number is a positive charge in the nucleus, which is known as protons. Hence, atomic number is more important than atomic mass. According to the statement of Henry Moseley, his law stated as properties of elements are periodic function of their atomic number. Students, do you know modern periodic table was also known as long form of periodic table. When we see classification of the elements in modern periodic table, the arrangement of the elements is in increasing order of their atomic number. For example, atomic number of hydrogen is 1. It will be placed in first box. Atomic number of helium is 2. So it will be placed in second box. Similarly, atomic number of lithium is 3 and it will be placed in third box in periodic table. Similarly, the other elements are arranged according to its atomic number in periodic table. Students, you have seen in modern periodic table, elements are arranged in accordance with their atomic number. As a result, most of the drawbacks of Mendeleev periodic table appear to be removed. Still, the position of hydrogen is not removed even in the modern periodic table. Students, we have also studied about electronic configuration in previous standard. It is a way in which electrons are distributed in the shell around the nucleus. Electronic configuration is determined by total number of electrons in it and we can say that the total number of electrons in an atom is the same as the atomic number. Here, the relationship between the atomic number of an element and electronic configuration is clearly seen in modern periodic table. Students, periodic table is the most important tool in the chemist toolbox. Now let us study about the structure of modern periodic table. As you can see in the table, the modern periodic table contains 7 horizontal rows called as periods. Similarly, the 18 vertical columns in the table are called groups. This arrangement of periods and groups results into formation of boxes. Each boxes corresponds to the place for one element. Student, when you see the table, the two rows are shown separately at the bottom of the periodic table. These are called lanthanide and actinide series respectively. The total number of elements in periodic table including two series are 118. Few elements was discovered experimentally and thereby the modern periodic table is now completely filled. To study the modern periodic table, the entire periodic table is divided into 4 blocks. That is S block, P block, D block and F block. Students, when you observe the periodic table, the groups 1 and 2 are included in S block. The groups 13 to 18 are included in P block. The groups 3 to 12 constitute D block, while the lanthanides and actinide series are placed at the bottom of the F block. The D block elements are also called as transition elements. Students, if you observe the periodic table, a zigzag line can be drawn in the P block of the periodic table. All the metals lie on the left side of the zigzag line, while all the non-metals lie on the right side of the zigzag line, and the metalloid elements lies along the border of zigzag line. Now let us learn about modern periodic table and its electronic configuration. So, if you see the modern periodic table, within the period, the nearest element differs slightly and the farthest element differ widely. For example, let us see in the third period. Atomic mass number of lithium is 6.9, whereas its nearest element, beryllium's atomic mass number is 9.6, and the farthest element, neon's atomic mass number is 26.180. Now, let us see example for how the elements in the same group shows similarity. The outermost orbit of group 1 contains 1 electron. For example, hydrogen, lithium, sodium, potassium have 1 electron in its outermost orbit. The electronic configuration of elements helps to decide the position of the elements and its characteristics. However, the properties of elements changes slowly while going from one end to another. For example, from left to right in a particular period. As you can see in the diagram, atomic radius decreases from left to right. Students, let us learn groups and electronic configuration of modern periodic table. First group contains the following elements: hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. They are also called as alkali metals. Group 1 element contains only 1 electron in its outermost orbit. Similarly, beryllium, magnesium and calcium belongs to group 2. They are also known as alkaline earth metals, and number of electrons in its outermost orbit is 2. Now, group 17, which belongs to Halogen family, consists of the following elements such as fluorine, chlorine, bromine, etc. And the outermost shell of these elements contain 7 electrons. You can observe the table which is displayed on your screen. It shows that While going from top to bottom, within any group, one electronic shells get added at a time. For example, elements in the first period have one shell. Elements in the second period have two shells. Elements in the third period have three shells, and so on. However, as we go down a group, the number of shells goes on increasing. Student, do you know atomic number of uranium is 92? All the elements beyond the uranium with atomic number 93 to 118 are man-made. All these elements are radioactive and unstable and have a very short life. Now, let us see periods and electronic configuration. On going through the modern periodic table, it is seen that elements hydrogen and helium belongs to period 1. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon belongs to the second period. Similarly, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon belongs to period 3. However, the number of shells is same. The valence electron in the outermost shells differ from left to right within the period. For example, in period 2, the valence electron of lithium is 1, beryllium is 2, boron is 3 and it goes on increasing by 1 as per the electron holding capacity of shells. Two elements are present in the first period, that is hydrogen and helium. The symbol for first shell is K. N denotes number of shells and its capacity is 2. Students, the second shell is known as L and its electron holding capacity is 8. The third shell is known as M and its electron holding capacity is 18. The fourth shell is known as N and its electron holding capacity is 32. Also, the general formula can be written as 2n square. According to the law of octet, the second and third period contain only 8 elements. The chemical reactivity of an element is determined by the number of valence electrons in it. For example, an atom of sodium has 1 electron in its outermost orbit and an atom of chlorine has 7 electrons in its outermost orbit. When these two atoms comes together, sodium atom donates its electron and chlorine atom accepts it. Thus, both acquire octet state to form sodium chloride. Hence, ionic bond is formed between them. When properties of elements in a period or the group is compared with its valency, atomic size and metallic and non-metallic character is called periodic trend. We have learned in previous standard that valency of an element is determined by the number of electrons present in the outermost shell of its atom. For example, let's see the valency of few elements from the table. That is, valency of hydrogen is 1, valency of helium is 0, valency of lithium is 1 and valency of beryllium is 2 and so on. Now let's move to the next topic, that is atomic size. Atomic size of an atom is indicated by its radius. Atomic radius is the distance between the nucleus of an atom and its outermost shell. Atomic radius is measured in picometer. As the atomic number increases from left to right within a period, the positive charge on the nucleus increases by 1 unit. Hence, the atomic radius goes on decreasing from left to right. As you can see in the table, due to the increase in nuclear charge, the electrons are pulled towards the nucleus to a greater extent and thereby the size of the atom decreases. Now let us compare the chemical properties of metals and non-metals. It is seen from the chemical formula of simple ionic compounds that the cation in them is formed from a metal while anion from a non-metal. Hence, it is understood that Metal atoms have a tendency to form a cation by losing its valence electron. This property is called electropositivity of an element. On the other hand, an atom of non-metal has a tendency to form an anion by accepting electrons from outside into its valence shell. A tendency to lose valence electrons to form cations having a stable noble gas configuration. This tendency of an element is called electropositivity. As it is displayed in the table, electronegativity and non-metallic character increases from left to right and decreases from top to bottom. So, the next characteristic is atomic radius decreases from left to right and increases from top to bottom. And the last characteristic is electropositivity and metallic character decreases from left to right and increases from top to bottom. Now, let us see gradation in halogen family. The group 17 contains the member of halogen family. All of them have the general formula X2. Change in physical state was observed down the group. Fluorine and chlorine are in gaseous state. Bromine is in liquid state while iodine is in solid state. Children, do you know a general chemical reaction of alkaline earth metals was observed with water? The reactivity of alkaline earth metals goes on increasing down the group. That is, beryllium does not react with water. Magnesium react with steam, while calcium, strontium and barium react with water at room temperature with increasing rates. So, in this chapter we have learned elements and the classification, Dobberinius triad, Newland's law of octaves, Mendeleev's periodic table, modern periodic table. Hope you all understood the lesson. Here we have finished learning second chapter. Thank you. Goodbye. Stay home. Stay safe.